Artificially enhancing the feeling of love through natural and synthetic chemicals is an emerging field of research that brings together neurochemistry, psychology, and even ethics in a fascinating interplay. Over the past few decades, scientists have begun to unravel the molecular secrets of love, identifying key players like oxytocin, vasopressin, dopamine, and serotonin, and exploring ways to modulate these systems with both naturally derived compounds and entirely synthetic agents. Imagine if we could harness these biochemical pathways to not only intensify positive emotions in relationships, but also to heal emotional wounds or overcome social anxiety. This topic prompts us to ask, what are the boundaries between naturally occurring feelings of affection and those that can be chemically enhanced? One of the primary natural compounds under investigation is oxytocin, often dubbed the love hormone. Research experiments involving intranasal oxytocin have shown promising results. Participants exposed to controlled doses of this peptide reported increased trust, empathy, and social bonding. For example, a series of studies demonstrated that couples who received oxytocin experienced greater emotional closeness during conflict resolution tasks compared to a placebo group. Similarly, vasopressin has been linked to long-term pair bonding in both animal models and human studies, suggesting that modulating its levels could influence commitment and attachment. Researchers have also looked at naturally occurring neurotransmitter precursors, such as tryptophan, for serotonin production, as potential avenues for subtly tuning the brain's mood and social connectivity. Can we envision a future where a carefully calibrated cocktail of these natural chemicals might help individuals navigate complex emotional landscapes? In parallel with natural compounds, synthetic chemicals have been developed to mimic or modulate these neurochemical signals. For instance, synthetic oxytocin analogs, which have longer half-lives or more targeted receptor affinities, are currently being explored in clinical trials for their potential to boost social functioning in disorders like autism spectrum disorder and social anxiety. Another intriguing example is the controlled use of MDMA, commonly known as ecstasy, which, in a therapeutic setting, has shown the ability to enhance emotional openness and bonding. Clinical trials investigating MDMA-assisted psychotherapy have reported significant reductions in post-traumatic stress disorder symptoms, partly attributed to its capacity to increase levels of serotonin and oxytocin. These synthetic agents provide a more targeted approach than their natural counterparts, raising compelling questions. To what extent can we design molecules that safely and predictably enhance positive social emotions? And how might these compounds be integrated into existing therapeutic paradigms? Experimental approaches in this domain often involve a combination of behavioral assessments, neuroimaging techniques, and biochemical analyses. Functional MRI, fMRI, studies, for example, have been pivotal in mapping the neural circuits activated by both natural and synthetic enhancers of love. In one landmark experiment, subjects administered intranasal oxytocin displayed increased activity in the ventral striatum, a key region in the reward pathway, while simultaneously showing reduced activation in the amygdala, an area associated with fear and anxiety. Such findings not only validate the molecular targets but also offer insights into how enhanced emotional states might be achieved without overwhelming negative side effects. Moreover, placebo-controlled double-blind studies have provided robust evidence for the efficacy of these interventions. Participants are often subjected to a battery of social tasks, ranging from trust games to conflict resolution scenarios, allowing researchers to quantitatively assess changes in behavior and emotional response. Have you ever wondered how a slight tweak in your neurochemistry could transform your day-to-day interactions? These experiments reveal that even minor adjustments in molecular signaling can have profound effects on our interpersonal dynamics. The potential applications of artificially enhancing love are vast. In therapeutic contexts, such approaches could be used to help couples overcome relational difficulties, assist individuals with social anxiety in forming stronger bonds, or even mitigate the effects of loneliness in aging populations. However, the journey from laboratory research to real-world application is fraught with ethical challenges. There is an ongoing debate about the potential risks of manipulating such fundamental aspects of human emotion. Could enhancing love artificially blur the lines between genuine emotional connection and chemically induced states? Researchers are acutely aware of these questions, and ethical guidelines are being developed alongside scientific advances to ensure that interventions are both safe and consensual. Looking forward, the field is poised to expand in both scope and sophistication. Emerging technologies such as CRISPR gene editing and nanotechnology-based drug delivery systems promise to refine our ability to target specific neural circuits with unprecedented precision. These advances raise intriguing possibilities. Could we one day tailor interventions to individual genetic profiles, or even create personalized love enhancers that work in harmony with one's unique neurochemistry? And what might be the long-term consequences, both biological and societal, of routinely enhancing our natural emotional states? In summary, the research into artificially enhancing love using natural and synthetic chemicals represents a cutting-edge intersection of neurochemistry, behavioral science, and ethics. By studying both naturally occurring molecules like oxytocin and vasopressin and designing synthetic agents that can modulate these pathways, scientists are beginning to unlock the secrets of emotional connectivity. The experiments conducted so far, ranging from neuroimaging studies to controlled clinical trials, offer promising results, yet also underscore the complexity of altering something as fundamentally human as love. As we continue to explore this fascinating frontier, it invites us to reflect on both the scientific possibilities and the deeper questions about the nature of human connection. What might the future hold if we can safely enhance our capacity to love? And how will these breakthroughs redefine our understanding of relationships, not just as a social construct, but as a profound biochemical reality? Love is driven by neurotransmitters and hormones such as dopamine, oxytocin, serotonin, and vasopressin, which regulate attraction, bonding, and emotional attachment. Researchers have investigated whether these chemicals can be artificially manipulated to enhance romantic feelings or prolong emotional connections. By understanding how these molecules function, scientists can explore potential interventions for relationships experiencing emotional disengagement. Dopamine is associated with pleasure and motivation, and its artificial enhancement through pharmacological means can temporarily intensify romantic attraction. Love neurochemicals function like a symphony. When balanced, they create harmony, but imbalances can lead to emotional detachment. Certain naturally occurring substances have been found to influence love neurotransmitters. Phenylethylamine, PEA, found in chocolate, mimics the effects of dopamine and is responsible for the feeling of excitement in early-stage romance. Other natural compounds such as L-arginine, which increases nitric oxide production, improve blood flow and physical attraction, while saffron has been shown to enhance mood and libido. Studies suggest that PEA levels are higher in people experiencing romantic attraction but decline over time, which may contribute to the loss of initial excitement in relationships. Natural love-enhancing compounds act like gentle stimulants, enhancing emotional connection without fundamentally altering brain chemistry. Oxytocin, known as the cuddle hormone, is released during physical touch, intimacy, and social bonding. Research has explored oxytocin nasal sprays as a means to artificially boost trust and emotional closeness in romantic relationships. While results indicate temporary increases in bonding behaviors, long-term effects remain unclear, and ethical concerns regarding its use in relationship therapy have been raised. A study demonstrated that couples who received oxytocin nasal spray exhibited higher levels of eye contact and perceived emotional closeness compared to a placebo group. Oxytocin functions like social glue, enhancing bonding and trust, but requiring real emotional interactions to sustain long-term connections. Such connections are essential for support, but also a natural reproduction process. Dopamine is central to the reward system and plays a crucial role in romantic attraction. Medications such as L-Dopa used in Parkinson's disease have been shown to increase feelings of motivation and pleasure, potentially enhancing romantic attraction. However, artificially elevating dopamine levels without emotional engagement can lead to dependency or altered perceptions of relationships. Individuals taking dopamine-enhancing drugs sometimes report heightened attraction and attachment to partners, reinforcing the role of dopamine in romantic feelings. Increasing dopamine artificially is like turning up the volume on a song, enhancing the intensity but not necessarily improving the quality of the connection. Serotonin regulates mood and emotional stability, influencing how individuals process love and attachment. Selective serotonin reuptake inhibitors, SSRIs, commonly prescribed for depression, can alter romantic feelings by reducing obsessive thoughts and emotional intensity. While this can stabilize long-term relationships, it may also diminish passion or excitement in new romantic connections. Research suggests that individuals on SSRIs experience reduced emotional highs and lows in relationships, leading to more stable but less intense romantic experiences. Serotonin modulation is like adjusting a thermostat. It smooths out extreme emotions but can reduce the intensity of passion. Vasopressin is associated with monogamy and long-term bonding, particularly in males. Studies on prairie voles, a monogamous species, show that vasopressin enhances pair bonding behaviors. Human trials have explored vasopressin-based interventions for strengthening romantic commitment, but its role remains less understood compared to oxytocin. Research indicates that genetic variations in vasopressin receptors may influence a person's likelihood of forming strong romantic attachments. Vasopressin is like a loyalty program. It reinforces long-term commitment but does not necessarily create initial attraction. Psychedelics such as MDMA and psilocybin have been studied for their potential to enhance emotional connection and empathy. MDMA, also known as ecstasy, significantly increases oxytocin and serotonin levels, leading to heightened emotional intimacy and trust. While some research suggests these substances may help couples reconnect, concerns about dependency and artificial emotional experiences remain. MDMA-assisted therapy has shown promise in helping couples navigate emotional barriers and improve communication. Psychedelics act like a magnifying glass, temporarily intensifying emotions and connections, but the effects may not last without deeper psychological work. The possibility of artificially enhancing love raises ethical questions about consent, authenticity, and long-term consequences. If love can be chemically induced, does it remain genuine, or is it merely a neurochemical illusion? Researchers debate whether these interventions should be used to repair struggling relationships or if they risk undermining the natural dynamics of emotional connections. Bioethicists argue that while love-enhancing drugs may help couples overcome emotional challenges, they should not replace genuine relationship-building efforts. Artificial love enhancement is like adding flavor enhancers to food. It may make the experience more enjoyable, but it does not change the core ingredients of the relationship. The future of love research involves developing safer, more precise interventions that support emotional connection without artificial manipulation. Advances in neurotechnology, personalized medicine, and AI-driven relationship coaching may offer new ways to enhance love while preserving authenticity. Additionally, understanding individual neurochemical variations could lead to tailored interventions for couples facing emotional disengagement. Scientists are exploring the possibility of using non-invasive brain stimulation to activate love neural circuits without the need for drugs. The future of love science is like fine-tuning an instrument, enhancing harmony without distorting the original melody.
My eternal light, you filled my days with golden fire. Like dawn that melts the frozen air, your love, my dream, my heart's desire, a whisper soft beyond compare. Your voice, like music, light and free, a lullaby the stars compose. Your eyes, two moons upon the sea, where every breath, in every sigh, I find your warmth. Your sweet embrace, in every breath, in every sigh, I find your warmth, your sweet embrace. You are my sun, my boundless sky, my world of light, my sacred place. Tonight, beneath the silver gleam, as love ignites the velvet sea, I vow my soul, my heart, my dream, forevermore belongs to thee.